This is section 7.2, number 9, and it says find the volume of the region between the graphs y equals x squared and y equals x to the fifth rotated about the line x equals 5. So again, this is one of those volumes of revolution, so we're going to have to use the disk or washer method for this section 7.2. Alright, so the first thing we should do is try to sketch this curve, sketch the region. Y equals x squared is our kind of comfortable parabola that looks something like this, and it will go over to the left as well. Y equals 5x is a line that goes to the origin and has a slope of 5, so it looks something like that. And I'm going to revolve this around the vertical line x equals 5. Let's first figure out where these intersect. If I set them equal to each other, x squared equals 5x, then let's see, I'll get them on the same side of the equation, and I'll factor out an x, and I'll see that these intersect at x equals 0, which is not a surprise right there, and x equals 5, which is right here. Okay, so that's where these two curves intersect. Now this is being revolved around this line, x equals 5, so it's revolved around that line. So when I look at this region, it looks something like this. They're connected there, and again, a cross section is going to look something like this, and it's not a disk, but it's a disk with the center taken out. It's a washer again. So I'll have to use the washer method here, and I've got to decide whether I'm going to integrate with respect to x or y. Well, this distance right here, the thickness of my washer, is a vertical distance. So this distance should be dy. But even if you didn't know that, for the disk or washer method, anytime you revolve around a vertical line like the y-axis or x equals 5, then you're going to have integrate with respect to y. So the setup for this is going to look like the volume is the integral from whatever y is going to from here to here of pi times the bigger radius squared minus the smaller radius squared, in this case dy. Okay, so that's the setup. So I should figure out where y is going from. Well, certainly the bottom, when x is 0, that's y equals 0. So that's the point 0, 0. If x is 5, that's the other place they intersect. What are these functions equal to? If x equals 5, y is 25. 5 times 5 is 25, or 5 squared is 25. So this must be a distance of 25. Okay, so I almost have it set up. Now I need to figure out what my bigger radius is and what my smaller radius is. And maybe I should draw another picture to kind of make this a little bit more clear. So I'll draw a larger picture and then we'll go back to this. So here's my region. Here's a line, x equals 5, and I have a line going to that and this parabola going there. Now, my bigger radius is this distance right here. That's the distance. If this is y, that's this distance right here. That's my bigger radius. Well, that's a horizontal distance, and this distance right here is x. So this distance right here must be 5 minus x. But remember, I'm integrating with respect to y, so I should figure out what that is. Well, if x, this is y equals 5x is this line right here, I could get that in terms of y, and I could say, well, that's the same as x equals 1/5 y. So 5 minus x is really 5 minus 1/5 y. And that's what's going to go in this first radius, 5 minus y over 5. Okay, let's draw this picture again to figure out what that inner radius should be. So I'll kind of draw this region again. But now I want this inner radius, this little radius right here, that's this distance right here. Okay, once again for this curve, This distance right here is x, and this is 5 minus x. But it's a different x and y, right? This is going to this curve, the other one was going to this curve. Well, for this curve, this is the line y equals x squared. Or if I solve that in terms of x, that's x equals the square root of y. So this distance is 5 minus the square root of y. So that's what I'm going to plug in right here. 5 minus the square root of y. Now at this point we've done all the hard work. We've set up the integral. The rest is just a little bit of algebra of simplifying this and then integrating. So the challenging part to this one is over. But if you'd like to see the last part of just integrating, you've got lots of practice doing that. Let's see what this looks like. It's the integral from 0 to 25. Let's take out that pi, because that's a constant. And let's square all these things out. So 5 squared is 25. I'm going to have 5 times y over 5. That's just going to be y. So 5 times negative y over 5 is going to be negative y, but there'll be 2 of those, so I'll have negative 2y. And if I square this one, I'll have y squared over 25 minus, okay, let's look at this one. 5 squared is 25. 5 times negative square root of y is negative 5 square root of y, but I'll have 2 of them, so I'll have negative 10 square root of y. And then negative square root of y squared would just be y squared. I'm sorry, y to the 1 power. Square root of y squared is just y. And then I'm going to integrate that with respect to y. Some of these terms can cancel out. I've got 25 minus 25, so that goes away. Some of them can be combined. I haven't done any integrating yet. This is all set up and then simplifying. So I've got negative 2y minus a y, so that would be minus 3y. I have 1 over 25 y squared, that's that one, and minus a negative 10 square root of y would be positive 10 y to the 1/2, or square root of y, either way. Finally, we're ready to integrate this thing. So this is pi times negative 3/2 y squared plus 1 over 3 times 25 y cubed plus, let's see, 10 times, well, it's going to be y to the 3/2, so I should divide by 3/2 or multiply by 2/3, all evaluated from 0 to 25. Now at this point, you can plug in the y equals 25 if you like, and just be done with it. If I plug in a 0, all these terms are going to go to 0, but let's see what this finally ends up being. Let's see. Negative 3/2 times 25 squared plus 25 cubed over 3 times 25. So you could cancel out one of the 25s there with one of the 25s there if you wanted to, plus 20/3, 10 times 2 is 20 over 3, 25 to the 3/2 minus 0. Now at this point, there's not a lot of benefit to doing more algebraically. You should probably just plug this into your calculator. So if you want to watch me plug into the calculator, that'd be fine. Otherwise, you can do that, but let's see what I get. 25 squared times negative 3/2 is that number, plus 25 cubed divided by 3 times 25 is 75. So now we're at this number, plus 20 over 3 times, 20 over 3 times 25 raised to the 3 halves, or 1.5, gives us this number. So, so that's that number, but then I've got to multiply by pi. So I'll multiply by pi, and I'll get about this number. So approximately 327.2492-ish. Again, I like this answer okay, but here it is rounded to something from your calculator.